Relations are like dating apps for hippie numbers, 1-to-1, many-to-1, 1-to-many, and even many-to-many. It's mathematical version of free love. Think of these as 4 types of social interactions, some exclusive, some popular, and some just too messy to be called functional. Functions are like well-organized machines. Every input leads to exactly one output, no surprises. But imagine a funky vending machine that randomly gives you chips or soda, and sometimes a refund, for pressing 5 with your nose. That's not a function. That's a joke. Every graph must be put on trial. The vertical line test acts as judge, jury, and executioner. If a graph gives more than one output for the same input, the vertical line brings the evidence, and the graph gets disqualified for violating the function clause. A graph that passes the vertical line test depicts a function. To know whether it's 1-to-1 or many-to-1, you run the horizontal line test. If it passes both, the function is loyal and exclusive. But if it fails the horizontal test, it's in an open relationship. Still honest, still respectable, just seeing other y values. Function notation f of x means the value/output of function f when the input is x. But every semester, at least one brave soul thinks it means f times x and proceeds to multiply, like he is reductio malformis incarnate. It's not multiplication. It's a name tag. F of x is just telling you who x's partner is. The difference quotient looks innocent until you forget to use brackets. That's when erroneous Bedmathius sneaks from behind, whispering lies like you don't really need to subtract the entire f of a, or distribute the minus sign however you feel. Use brackets. Keep the demons at bay. Finding the domain is like checking the list of ingredients on snack bars before handing them to your kid. You look for anything dangerous: peanuts, gluten, division by 0, square roots of negatives, and if it's not safe, it's off the menu. Just because it's wrapped in math doesn't mean it's edible. Polynomials are like open highways in Germany. No speed limits, no holes, no crashes. Drive freely across the real number line. This is Aziraphale's favorite domain question on the final exam. He hides in the denominator, waiting for students to forget that dividing by 0 opens the hell gates of algebra. He watches when your teacher is grading your paper and he grins wickedly when you lose marks. Exclude all the numbers that make the denominator equal 0 from the domain. Banish the demon. Root in the numerator? Just make sure it's not imaginary. Denominator still needs attention though. Some values still aren't invited. Having a square root in the denominator is like walking a tightrope over a pit of imaginary numbers. You're not just avoiding 0, you have to stay strictly above it. The denominator must be positive, or the function collapses into undefined madness. In real life, functions are everywhere. Prices, temperatures, driving, social success, and emotional breakdowns before finals. If it changes when something else changes, you've got yourself a function. Y is a function of x is a mathematician's way of saying y depends on x. For example, the amount of salsa spilled on your shirt is a function of how many tacos you attempt to eat while driving. Or your GPA is a function of how often you mistake f of x for f times x. Here's another example you might find familiar. How bad your heart aches in the morning is a function of how many miserable texts you sent your ex at 2 a.m. George Functionton led the Great Revolution against ambiguous outputs. Before his time, relations were wild and unpredictable. One input could flirt with multiple outputs without consequence. Functionton couldn't stand the chaos. He drafted the function clause and declared that every input deserved one, and only one, loyal output. Thus, the function was born. Legend says he carried a vertical line in his pocket to every lecture. His tombstone reads, "He died enforcing domain restrictions. May his inputs rest in peace."